Water, the divine substance and one of the most important chemicals which makes up 2/3 of the human body. Drinking pure water affects the entire life process, helping to flush out toxins from our body. But are you sure that the water you drink is really pure? Drinking impure water can lead to a lot of health hazards. This includes diarrhea, vomiting, and even some kinds of cancer like leukemia that can happen after drinking bad water for a long period of time. According to UNICEF, 70% of industrial wastes are dumped untreated into water, and more than 3,000 children die every day globally due to the consumption of contaminated drinking water, especially in developing countries such as India and other African nations. From the research that we have conducted, most contaminants range from bacteria and viruses to heavy metals as well as inorganic and organic pollutants. However, current purifiers available in the market may not be as effective as we think they are. We have identified that the 4 biggest challenges of existing water purifiers are their short lifespan, their lack of feedback to the extent of water purification, the long purification time needed when chemicals are used, and a system that perpetuates the growth of microorganisms. So, what have we done to solve these obstacles? Introducing Project Mizu, a search for purity. Project Mizu is a water filtration system attempting to clean most impurities present in water. Utilizing our technology, we can successfully filter out contaminants from unclean water with a solar panel installed on the top of the cap, as well as a light system which assesses the purity of the water. The collaboration of all components are designed to optimize the water quality of our filtrates. So, how does it actually work? The process begins by collecting water from a contaminated source using an outer bottle. This is followed by sealing the inner bottle with a filter and pressing it into the water, utilizing the water pressure generated to drive the impure water through the filter to produce clean water. A cap with a light system is sealed on top and will produce a green light when it is safe to drink. Now, let's go deeper into the functions of each structure in detail. With 4 layers built in the filter, the water you drink are ensured to have the best quality. The 4 layers are the macro wire filter, followed by the ion exchange resins, then the nanocellulose with silver zeolites, and last but not least, the activated carbon powder. Our filter is attached to the bottom of the inner bottle. As water flows upward towards the macro filter due to water pressure, large insoluble substances such as sand, dirt, and mud will be filtered out as they are larger than its pores, completing the first step of the filtration system. Step 2. We adopted an innovative ion exchange resins filtration system. With this system, heavy metal ions such as sodium ions, manganese ions, and copper ions will be separated from the water due to their attraction towards the cathode with a current supplied from a battery storing energy generated by a 5-volt solar panel. Positive and negative resins contain hydrogen and hydroxyl ions respectively. Heavy metal ions in water will be attracted towards the negatively charged resin, which contains hydroxyl ions, while negative ions such as chloride and sulfate will be attracted towards the positively charged resins and displaces the H+ ions and the OH- ions respectively to the water flow. Then, a current applied splits water molecules into hydrogen ions and hydroxyl ions. The flow of hydrogen and hydroxyl ions will exchange the trapped heavy metal ions from the resins, restoring hydrogen and hydroxyl ions in the resins. The attraction created by the cathode and anode will displace the heavy metal ions in the water into the reject streams, creating a simultaneous backwashing and regeneration process. This removes up to 98.5% of most existing heavy metal ions, and they can be instantaneously removed compared to the long waiting time needed for the absorption of heavy metals on the resins without the supply of current. As most ion exchange resins have a lifespan of about 2 days, this technology will theoretically increase the lifespan of these ion exchange resins indefinitely due to the continuous regeneration process, as well as providing instant purification for the contaminated water, solving the short lifespan and long purification time exhibited by existing water purifiers. Moving on, the installation of interweaved nanocellulose filter of about 19 nanometers, which can be widely found in nature. Alongside with its high mechanical strength, flexibility, and chemical inertness, it also stops proteins such as immunoglobulin G, as well as viruses like hepatitis C and HIV from passing through. Having filtered out most of the contaminants, we believe this filter would be one of the most efficient and effective filters currently available. Yet, we decided to take this up to another level by installing a layer of powdered activated carbon to further filter heavy metals, remove dissolved organics, and chlorine residing in the water. But the greatest game changer is our feedback system, a TDS sensor that is installed in our water purifier, which detects the concentration of ions in water. Our TDS sensor acts as a feedback system which indicates the concentration of heavy metal ions within the water using a programmed lighting system which displays colors of green, yellow, and red. As 400 milligrams per liter is the standard concentration of total dissolved solids set by the U.S. Environmental Protection Agency, a green light indicates that the water is safe to drink and will produce a yellow color when the concentration of total dissolved solids exceeds the standard, with a red light indicating very dangerous levels, signaling that recharging is needed for the optimal performance of the ion exchange resins. With the plastic outer layer and inner parts of the purifier lined with stainless steel, there is no need to worry about bacteria cultivating inside the bottle, as well as corrosion due to the exposure of acids and bases. In general, it also decreases the weight of our water purifier as much as possible. Another edge is our water recovery percentage. We can proudly say that a recovery percentage of 85% can be produced by our water filter with a reject of approximately 123 cubic centimeters. Indeed, this innovative water purifier is like no other, but with so much complex materials, would this still be marketable? This is where the unfair advantage comes in. By encompassing all the materials needed to construct this water filter, the total cost of our filter, just based on the materials needed, is just about $5. This bottle will be a lifesaver whether you're living in the slums of India or a traveler anxious of the water's quality. We at Project Mizu search for purity in water across the globe. With a near limitless lifespan and a low cost, we break the impossibility while saving countless lives at the same time. Imagine if everyone near contaminated water sources get their hands on this revolutionary portable water filter. We would prevent 500 and 2,000 diarrheal deaths as a result of unsafe drinking water, 240 million victims of parasitic worms, and be the solution for the 2 billion people who depend on unsafe water sources. Become the pioneer of purity and rediscover the water for life. Project Mizu.